All right, well, thank you, everybody. So my name is Devin McGreal. I work with Cascade Natural Gas. We're a natural gas-only LDC. So I think I bring a little bit of a unique perspective. I apologize. I know there's a lot of electric folks in here, so I'm going to be talking a lot in natural gas terms, so hopefully I don't lose anybody, but we can get to translations if we ever need to. I do want to start with a little bit of an anecdote. So last year was my first Energy Exemplar conference at the Nashville conference. And at the reception we had over there at the Country Music Hall of Fame, which was fantastic. Great job, Energy Exemplar again. Everyone looking forward to Universal, I'm sure. So I was talking to a lot of individuals about renewables. And the conversation really came up and I said, you know, solar, wind, you guys are doing a lot of great things. Do you guys ever look at renewable natural gas as an option? And the gentleman that I was talking to looked at me and said, gas, but you guys are the enemy. And I said, it doesn't have to be like that. And I think that's an important thing. We had a lot of really good presentations that have talked about the resource deficiency conversation on the electric side. And I think that's where natural gas has a key role. But in order to do it, we're going to have to be a good steward. We're going to have to, as an existential threat, frankly, we're really going to have to find our role to decarbonize all of our gas systems, to hit these environmental emissions reduction goals that our states and, frankly, our country and the world have and should be looking at. So that's what I want to, whoops, I did not want to do that. How do I move it forward next? Excellent. So here's our disclaimer. Once again, this is all for informational purposes. Any information that we're publishing is either publicly available information, or if it's not publicly available, it's just informational numbers, no actual numbers. This is not investment information, so on and so forth. So Cascade's use cases. So we started as a PLEXOS customer in 2022. It's used for our integrated resource plan, which my colleague in the audience is one of our main modelers for as well. And we mainly do comprehensive scenario and sensitivity modeling. So we're going to look at, our states really want us to look at how are you going to be able to continue to serve your customers from a least cost, least risk manner, with that new caveat, once again, of being able to hit our emissions reduction goals over that 20-year planning horizon, and frankly going all the way out to 2050. In recent years, the Pacific Northwest has undergone this significant decarbonization effort. And PLEXOS allows us to model these emissions reduction requirements that we're going to need to meet in the form of, or for Washington's Climate Commitment Act and Oregon's Climate Protection Program. I'm going to give a little bit of context about these two policies. Like I said, I know a lot of people here are electric, may not have a ton of exposure to this, although I do believe there are requirements for both of these and analogous ones for the electric industry as well. Climate Commitment Act is in Washington. For this policy, Climate Commitment, that's Washington, sorry, for this one, no natural gas allowances for natural gas supply, or no cost allowances are given to us natural gas suppliers. So this chart kind of shows all public information, what we are given as our no cost allowances. And it's a declining amount. We're supposed to be able to continue to reduce our emissions over time. And it starts as a really steep trajectory and then starts to level out a little bit. We got our first no-cost allowances in 2023, September of 23. In 2024 and thereafter, they are given to us in the October of each year prior. So you have to be able to, if this is what your no-cost allowances are and you have targets that you need to hit, you're going to have to find a way to bridge that gap. And we use PLEXOS to help us figure out what's going to be the resource mix to bridge that gap ultimately. Climate Protection Program in Oregon is very similar. The rule is currently invalidated for those paying attention to it. They're actually in active rulemaking right now to reinstate it. We expect it should be back around 2025. The main kind of nuance to this one, you can see it's a similar declining cost curve. The main nuance to this one is you do get some compliance instruments. You're also allowed to purchase what's called Community Climate Investments. I believe CCIs, that's what the acronym stands for. But basically, we can invest dollars in the state and a state-run program. It's used, they find a counterparty to reduce emissions. And so it's a fixed target price, and that's another compliance instrument. That's another resource that we can put into our PLEXOS modeling to be able to figure out what is going to be that optimal way to hit our emissions reduction targets to, once again, be a gas utility that is a part of the solution. So our CCA compliance options, what are the tools that we ultimately are going to put into PLEXOS itself to do that optimization and figure out what's going to be available to us? So renewable natural gas, that's a big one that I already talked about. And I do want to spend a little time about this I talked to somebody during this conference, and they said, so what is renewable natural gas? You hear renewable wind, you hear renewable solar. What is renewable natural gas? Well, I'm not a technical expert, so if you ask me how it's created and put in the pipelines, I'm not the person. But I can give you a top-level overview. In the main form, it's going to be from your landfills, from your wastewater treatment plants, food waste. Dairies are a big one as well. Basically, methane is escaping from these various facilities, processes, entering the environment. And we have an opportunity to prevent that from escaping, clean it up to become pipeline quality, throw it in our pipes, and be able to serve our customers through that. We can power many households, businesses through that renewable or bio-natural gas. So that's a big one that we deal with for the Climate Commitment Act, the CCA. Allowances is another big one. So some of you may be familiar with California's program. They have a very similar cap and trade program. Our program was actually modeled after that program, where we can go into these quarterly auctions. We have the ability to go in there and bid on a certain number of allowances. One allowance reduces 1 metric ton of your emissions. This is another input that goes into PLEXOS. So if you think about it, we're starting to build what the model might ultimately look at, right? So we've got one option in renewable natural gas, one option in these allowances, these kind of state subsidized, or state allowed for resources. What's going to be the mix that's going to be able to serve our customers and reduce our emissions in that least cost, least risk manner? We've also got offsets. Climate offsets are a big thing that's happening on our world right now. There's compliance offsets and voluntary offsets. We're going to deal in those compliance offsets, the ones that the state specifically allows you to utilize for a program like this. That's another one. It's got its own price forecast with it, its own availability. There are certain restrictions that you have to model into PLEXOS about it, because you can only utilize a certain number of those offsets towards your compliance goal. So that's another thing where you're using PLEXOS to put in those constraints to figure out layering what's going to be that optimal mix. Energy efficiency is also another big one. Conservation, demand side management, going in there, doing an avoided cost calculation, figuring out what is that optimal mix of energy efficiency, because that's going to change now. You know, we're starting to have conversations with some of our larger industrial customers about, are there energy efficiency programs that we can do for you that initially may not have been cost effective, but now with these additional costs layering in, we can add that in as well to once again reduce our emissions towards that ultimate goal. And then finally, hydrogen. I think hydrogen is a fascinating subject that there's a whole lot of conversation that still needs to happen about, but I think it's a very positive, optimistic resource that I, for one, am very bullish on. The ability we can utilize hydrogen to, whether it's blend in our pipelines, we already have this existing infrastructure that we can leverage, blend it in there to be able to produce a product that may not be at that point 100% clean, but can be a transitory product. Or it could be used in a dedicated hydrogen system where it's a fully 1%, you have an industrial customer might come online and say, hey, I have these gas needs, but I want to do it in a clean manner. You could get them gas appliances or hydrogen gas appliances and have a 100% hydrogen system for them. There's an opportunity there that we're very excited on. That's still in very nascent stages, but we're very excited about the opportunities that. And bringing it back to PLEXOS, that's another resource now that you're going to have to put into PLEXOS with its own constraints, with its own challenges. Moving on to the Climate Protection Program in Oregon, I'm not going to go into all this again, but it's a very similar thing ultimately. A lot of the same resources are being utilized. The only difference is these community climate investments. The one thing that's interesting about this program is you have these limits to what you can utilize. So 10% in compliance period 1, 15% in compliance period 2, and 20% in compliance period 3. What this ends up ultimately meaning, it's not a percentage of your gross demand, it's a percentage of your demand less any other green resources like renewable natural gas or hydrogen that you're utilizing. So when you're building that into your PLEXOS optimizer, you have to put that constraint in place, but it's a constraint on a number that is going to iterate off of other things. Because when that optimizer is figuring out the optimal resource mix, it's going to be looking at things like how much RNG do I want in the relationship to how many CCIs do I want in relationship to how much hydrogen do I want, and that number is going to be able to, it's going to have to constantly iterate on itself. So it's a fascinating challenge that we're actively working on in our PLEXOS modeling. So everybody went to their training sessions, I'm assuming. I'm sure we've seen grid views. This is, I think we did this one in Visio, but it's essentially a PLEXOS style explanation of how do you do all of this compliance modeling? How do you take all of these pieces and have them work together? So we see a lot of the things we talked about. There's just the traditional way that we as a gas utility do business, right? We have our upstream gas supply. We move it to a demand node. That's where we record our emissions. And then that ultimately goes to your house, my house, and a factory somewhere. But then we've got all these other tools that we can do to either reduce emissions by avoiding this node altogether and just making it to this demand node, doing it at no emissions, and that's through on-system RNG and hydrogen. So we're in the Pacific Northwest. I live in an area called Kennewick, Washington. We actually have a landfill, it's public, that's 15 minutes from my house that we just broke ground on, and we're getting some of the environmental attributes from that project. What's going to end up happening is, as it's being cleaned up, that landfill, and that gas is being put into the system, that is now going to offset the need for us to buy some of this traditional upstream gas and move it over here. That is a avoidance of emissions. It's not a negative emission, but that's an avoidance of an emission. But then there are the regulatory, the compliance tools that I talked about. So there's these over here where you can utilize those community climate investments or those allowances for those of you who might be familiar with the cap and trade programs. When you're doing PLEXOS modeling, that actually ends up being recorded as a negative emission because it's directly offsetting the use of one emitting resource. Instead of it avoiding the use of this, it's allowing this to still flow through and then offsetting the use of it. There's also off-system RNG hydrogen. The gentleman before me, I think, used an analogy, or explained the virtual power purchase agreements, and I think it's kind of analogous to that in our world, where I can go to a landfill in Kansas, for instance, and say, I only want the environmental attributes from your project. I don't necessarily need the natural gas from your project. That natural gas can go to a local distribution company in Kansas. Instead, I will take those environmental attributes and once again record a negative emission for having that. So a bunch of different ways to model this, that you ultimately throw all of these things into PLEXOS, you calibrate it based on all of those factors, and the result that you get is your least cost, least risk plan. I'm going to talk a little bit more about each one of these factors though. So the regulatory compliance instruments, this is the way we look at it, they're the lowest risk. There's the most certainty around these instruments. When I go to an auction, or if I go to the state and give them a bucket of money, I know for a fact that I'm going to get credit for 1 metric ton of emissions reduction. That's ultimately what ends up happening in this. It has a negative emissions impact. So this gets back to what I was talking about before. It's not displacing the use of natural gas. It's actively telling the system to reduce what your total emissions balance when you have that constraint that you can have 2 million metric tons, let's say. It's reducing that balance for every one of these things that you purchased. But there's also no gas involved in this process, and I think this is one of the interesting modeling quirks that we've done in PLEXOS with this. So in PLEXOS, everything that we model as a gas utility is all gas. So what ends up happening is at this Washington auction node, what you actually have is a supply of gas that includes a negative emission factor, -1 metric ton of emissions. So you end up over here, you go, and at this auction node is where you purchase however much of this. So the price of this transaction is whatever the price you forecast it to settle at that auction for. You can also hold these. So anybody who's dealt with compliance accounts, you have the ability to purchase these and not necessarily use it now, but use it later. But there is a constraint to that. It actually, just by chance, works really similar to a storage facility where there's maybe only so much storage you can have. So you store this product, this compliance instrument, even though in PLEXOS' perspective you're calling it gas, you're storing this compliance instrument in this holding tank. And then you withdraw it whenever you need to actually utilize that compliance instrument, and there's no cost to doing that. That's just happening where I'm going into our account and saying, okay, I've got it in a holding account. Now I want to actually utilize it for a compliance account. So once you've kind of figured out what you want to do with that, you use this free logical transport and the emission is recorded in this node over here. So this is where you end up having, in this PLEXOS node, the fact that 2,000 pounds, so 1 metric ton of CO2e, is retired at this node. That's when PLEXOS is doing its calculation for what your total emissions are. It's reflecting this. But you've still got a problem here. We bought gas up here. We have gas over here, gas over here, gas over here. You still have gas in your PLEXOS system. And this is kind of weird because PLEXOS doesn't like it when you just leave gas in your system. It'll give you all kind of weird errors. It'll try to want to do something with that gas. So you're going to have a problem. So what you need to do is now remove the gas from your system altogether. And that's where you can use the markets function in PLEXOS, where you create a market, and this, you have it be free. So basically what you tell PLEXOS is after you go through all this, because you've recorded your costs up here, and you don't actually have gas. So you just want to get rid of the gas and not have an actual cost. That's what you do over here is you make this market, and you just say, PLEXOS, go ahead. Once it's time to retire it here for free. Goes down here, removes the gas. PLEXOS optimizer loves it now. It can flow through perfectly. So this is one thing. This works very similar for Oregon for our community climate investments, that CCI instrument as well. This is talking about off-system hydrogen. So this one's a lot easier. It's a medium risk. I call it a medium risk impact because when you're modeling, and this starts to get into some of that stochastic versus deterministic analysis that I know we all need to do. When we go to this project, I use the example of a landfill in Kansas, right? Where I go to them and say, all right, I want to buy 1 million RTCs, renewable thermal certificates, for those in the energy world, very similar to your RECs. I want to buy 1 million of them. I'm going to make an agreement to buy whatever you come from that landfill, and we're going to assume that it's 1 million. Anybody who has dealt in projects like this know there's always problems. So you're going to have risks like it might not get online when you're expecting it to. There's going to be risks around weather. Unfortunately, as a gas utility, our peaks are winter peaking, obviously, and that's when a lot of the landfills won't produce as many renewable thermal certificates as you'd like. So there's a lot of uncertainty that we're still pretty new to this market. So the gas world's pretty far behind the electric world on this. So we're still learning. Whoops, let me go back. We're still learning a lot about what might the actual risks be here, but that's stuff that ultimately we're going to want to be able to put into our PLEXOS model as to what might be some of the stochastic inputs around what could ultimately be produced on a winter day. I think somebody talked about the ability to use weather and have some of that weather-based stochastic modeling. I think that's something that we're going to ultimately want to iterate into our model, because I think that'll be a very valuable way to try to get that. But we still need to gather data for that. We need to get a better idea of ultimately what is going to happen on that winter day, what might be the risk bands to be able to do that stochastic modeling. The last thing that I want to talk about is our regulatory compliance instruments. Regulatory compliance instruments related to on-system gas. So this is that example I told you of that landfill right near my house. So this is by far the highest risk thing that we can put into our PLEXOS model. It has a zero emissions impact. This is, once again, this is avoiding that. If I go back a couple of slides, this is avoiding this process over here that none of these other two can. This avoids that process by kind of just cheats over here and sneaks to the demand node, avoiding this emissions recorded. So at that landfill, once again, near my house, we're able to get it, clean that gas up, put it in the pipes, deliver it to my house and wherever at what's considered a clean zero emission resource. There's a lot of risks with this being an on-system project, mainly that we're going into these projects as investors. So instead of it just being a purchase contract where I say, we're going to do $25 per RTC, you're going to deliver me whatever you get, and we call it good, I have to go to this developer, go to this landfill and say, all right, I want to be a partner with you on this. Since I'm partnering with you, I'm going to be investing $10, $20, $30 million into this project. And in exchange, I'm going to just get those credits, not at a fixed price. I'm going to get whatever you produce. Now, there's variants that you can do on this. Sometimes you can end up getting it at a discount price. Sometimes you get all of it. But that's basically the concept of it, is we're going to go as a utility and invest in this project, and in exchange, we're going to get those credits that you end up generating from this. So in addition to the last slide, where there's the timing credits of it, of what's going to happen? Is it going to actually come online in 2025 as it's scheduled to, or is it going to come online in 2026? Are there delays? Is there a cold weather event that's making it not produce? That's one risk, because in the prior example, my only risk in that situation is I'm just not going to get as many credits. But now, when I've made this, my calculus on deciding if this is a cost-effective product, because it's based on that one fixed lump dollar investment on year one, well, all of a sudden, I've gotten less of a variable resource for that fix, so those costs may not look as favorable. On top of that, anybody who's ever dealt with construction, there's always cost delays, there's always cost overruns when it comes to projects like that. So that's another risk now that you need to find a way to put into PLEXOS. You need to be able to say that, okay, what might be my stochastic bands on cost overruns, so that when I'm trying to figure out, taking this one fixed investment and figuring out what the variable impact might be, in relation to all of those other potential options, putting all of that into PLEXOS, and hopefully the optimizer returns to me what that, once again, that least cost, least risk resource mix is going to look like to be able to meet my 20-year or 26-year compliance obligation, because all of our planning goes out to 2050. So that's really all I've got on this. If anybody's interested in what the result of that was, our integrated resource plans are public on our website. Definitely encourage everybody to check that out. And if you have any questions, please feel free to reach out to me about how we did it, what the results ultimately look like. More than happy to answer those questions. Thank you.
Devin, you have a few minutes you want to take? Does anybody have any questions for Devin? Great presentation.
So for the RTCs, the credits, is there an associated penalty price from the state if you do not have enough credits to produce?
That is a fantastic question. The answer is probably we wouldn't even consider it. It's part of our modeling is at this point, we're not comfortable with even evaluating a scenario where we don't have enough credits to meet our compliance obligations. So we don't even, at unserved demand, when you're doing PLEXOS modeling, you can set a $1,000 penalty price, whatever. We will not even entertain that. We just straight up say that's not an acceptable outcome in the optimization.
Got it. Thank you.
Hi. What kind of volumes of RNG is your model saying actually move on any given line?
Yeah, so I can think about it from an entire system. Theoretically, we don't identify any constraints as to what could do it. So we could utilize our entire system with RNG. We don't see that as a potential problem. In terms of practically what it's actually doing, we're actually getting an updated study done right now to try to get a better idea of what might be that nationwide potential for that. In terms of actual practice, the projects that we have that I think are pretty much all public at this point. There's a pretty big landfill in Bend, Oregon that we're a partner on, and then the one that I talked about near my house. I think of actual RNG that's in the short term going to be flowing in our system is close to 1 million decatherms, which would be 1 million RTCs. 1 million of that unit of RNG is what we have under contract at this point at the utility. And we're still constantly looking for more opportunities. So we're always evaluating more to throw into PLEXOS to see if it's cost effective and add to our system.